that right?
I watched the second video because of that reason.
Is that right?
But it's too noisy.
This is really helpful to know. Okay. Okay. So I'm going to try to diagnose this problem, ideally before last lecture. It's okay. I think I know what I'm going to do. I think I'm going to get a new microphone. Okay. Can I tell you how grateful I am to know about this issue? This is really helpful, and I will try to act on it as soon as possible. Okay. So hopefully by Thursday I'll have something different. So thanks much. Maybe Kurt, since you're nearby, maybe you can help advise me about particular videos that I send out, and you can tell me kind of yay or nay. The other thing is I have audio files for a lot of the video created in my pocket. And especially if some elf could help me with it, if I could splice in that audio, then the audio will be crystal clear. So maybe there's something we could do there, but it takes a bit of work. Okay, great feedback, fantastic, thank you. Any other comments or questions right now before we look at maybe an example or two? Yes.
When we talk about different kind of food, for example, in the diagram, we just say that it's positive or negative, yeah. And sometimes one variable in a system will change, and some point it's common between several loops.
Yes.
I think it may sometimes show some growth or sometimes show some decrease in some effect, because
Right.
the amount of difference and change in different loops may be different, yeah?
Mm-hmm. Yeah, that's true. So I think I understand some elements of what you're saying, but actually this would be, I think, much clearer if you could actually give an example, which might illustrate some features of this.
If we have some diagram in the...
Okay, so some diagram here.
Yeah, for example, a point when it's under 2 loops.
Under...
Yeah, we have one element which is common between two different loops.
Between two different loops, okay. So I think we have some of those a little bit further on. Okay, so here's some loops on the left-hand side, and then there's a loop on the right-hand side, and something like morale is common to both loops.
Yeah, one
Okay.
positive and one negative.
Okay. So here we have these are both. So you can tell me. Okay. So first of all, is this a positive or negative feedback loop? This one on the right here. Positive feedback loop. And we know that because it has, yes, it has an even number of negative signs. How about this one here? It's also positive. So can anyone kind of give me a narration of each of these loops? So how about for this one here, morale and resignations? Can you give me a sort of a little story that might go along with that? So how would you sort of describe how this loop operates? What is this loop telling you? That okay. And when they quit, what happens? Okay, well that's true for this loop. But how about this loop in the upper right? The morale will be further decreased, which may lead to further resignation, right? So some of your buddies leave the project, and you start thinking about leaving the project, and it gets sort of worse and worse. Okay, so that's good.
I have a question.
Yes.
As I was thinking about making my own diagrams, I was realizing, and this was talked about with having more than one loop, that if you have one loop, sometimes increasing, if you have a resignation, if it's the right person, then morale goes up.
Correct. Oh, okay. Yes.
Right. So sometimes the relationship between morale and the resignations could be bimodal.
Okay. So this is an interesting. question. And
I don't know how to encode that.
okay, so resignations. So if I wanted to say some resignations improve morale of the remaining people and some lower morale.
Like you could have a manager left,
Yeah.
and then a lot of people were promoted as a result.
Yeah.
Maybe morale would increase because now you have a bunch of people that are happy to have a new job.
Okay. So right. So where is the link here? This is not a trick question. Where is the link that is shown as kind of associated with the relationship from resignations to morale? Well, it's right here, right? So what you're saying is we might want to unpack that into more pieces. And I do show an example earlier.
Maybe we're getting away from his original question. I don't want to do that.
Yeah, I did show an example earlier of kind of, this is a kind of ambiguous case where, okay, if I increase overtime, does it increase or decrease the amount of work I get done per day? Well, it depends, and more importantly, how it depends over time kind of depends on different pathways. You might call these different pathways by which this can affect that, right? So one pathway by which it can affect, one causal chain would be another word. So one pathway by which it could affect that is, overtime leads to more time working, which leads to more work accomplished per day, all the things being equal. Mm-hmm. So I spend more time working, my nose to the grindstone, and spending more time working, getting more done. That's kind of one naive pathway that operates pretty well in the short term. If you put in a spurt at work, and you do that for a couple extra hours one night, that's fine. But the other components are a little bit more distal, but sometimes they kick in. Takes longer, but they're very large effects. In some industries, like software engineering and construction, these effects have been measured quite a bit. The data I've seen from construction are absolutely striking. It's like after 4 weeks' time, working overtime buys no extra productivity. No extra. You're working longer hours, but there's no extra productivity. I'm not talking productivity per hour. I'm talking no extra productivity compared to what you would have had. After 8 weeks of it, it's negative productivity. You're actually getting a lot less done than you would have otherwise. People are grouchy and going on sick leave and they're sloppy and fatigued, so they're making bad decisions. Let's demo hammer that out, boys, and and they end up making silly mistakes, getting injuries at work, etc. So here, overtime leads to, over a long period of time, this is the delay, indicating a long delay, relatively speaking, compared to other things, leads to fatigue, and fatigue lowers efficiency, and efficiency, of course, impacts work accomplished per day. So this is a case where we have unpacking to do, Kurt, and I would say for your case, there'd be unpacking on how resignations impact things. It may be that resignations lead to opportunities to shift jobs, which are positive. It may be that it leads to, or shift skill, shift work assignments or work duties, which can be positive. But it can also lead to, of course, many of the other effects captured in the other diagram, including more work, and in a sense of kind of loss of friendship and so on. So I think you'd want to unpack those things, and different ones of them will be, I think, more dominant in different situations. But I think what you're getting at is also, could a diagram like this really capture the full texture of the situation, right? The type of person who resigns. And Kurt, you might distinguish managerial. Like if it matters, is it managerial resignations or worker resignations? You could actually unpack that with different variables if you thought it was important. But do you have an example? Your name? Yeah, please, Fahad. So yeah, do you want to? Fantastic. I appreciate Fahad's leadership and putting something up. So.
I just try to
Yeah.
draw it out.
Okay. Okay, so people in the class, is that a negative or positive feedback? Okay, there needs, yeah, negative feedback, right? So one thing Fahad is also showing with this diagram is that sometimes arrows are put in the middle of loops and sometimes at the end of loops. And Benson gives you that same choice. So you gotta decide, you gotta right click on the arrow if you want the arrow to be in the middle of the loop, I think. You could kind of decide which place you want, or where you want the label to be.
Is a negative go
It's
to the arrow?
the label, I'm sorry, not the arrow, sorry.
The polarity of it goes to the arrowhead?
Yeah, it's the polarity is the key thing, the label. I should have said polarity. Yeah, it's the label of it. And so it by default it goes to the arrowhead, but you can set it so that it's with the so-called handle. That's the little thing by which you drag it. Yeah. So okay.
Here we have two, one positive and one negative.
Okay.
Yeah. Sometimes I was wondering, even sometimes modeling help us to understand some feedback from the model. For example, we have a factor, an element here, anything.
Sure.
We change it. We have a positive loop that
Yep.
try to improve those effects.
Good.
Yeah. Here, for example,
Yeah.
we have a net improvement in something, but in negative loop we have a decrease in it. Sometimes this positive loop overlap and make this one disappears. Yeah.
It makes it.
The impact of this
Overlap.
this decrease will be disappeared in the system.
Oh,
There's
okay.
nothing visible.
Yeah. So it overrides it
Yeah.
in a way. It sort of is stronger than it.
Yeah, exactly.
Yeah. Yeah.
What
So this is
happened in
frequent.
this kind of things in
Okay.
this situation?
So the answer is, and I don't think this was something in the one I would have shown. So beautiful illustration. The answer is that is a very interesting one, and it gets down to the technical underpinnings of this. If we represent situations like that, we often have what's called shifting dominance of different feedback loops. So you see here some graph for the number of customers of a situation, right? And you'll notice here it increases early on, kind of faster, and then slower, okay? It's faster and faster, then slower. And it turns out that this is due to a shifting dominance among these loops. We could say one loop dominates in one phase, one loop dominates another. What loop do you think dominates in this sort of early phase here? Well, it's the red one. It's the reinforcing feedback. How do we recognize that? Well, it's growing faster and faster. It looks almost exponential early on. I mean, it's getting faster and faster. But then it starts being balanced out by this one. Okay, and we say this one dominates later. And if you go and you look at a lot of complex phenomena, and I have this, here. Oh, come on. What I'll show is there's actually, oh man, it's down here further than I thought. Sorry, folks. So you get, it turns out if you represent these things in stock and flow diagrams, we'll see these feedback loops go into stock and flow diagrams. Okay, they form that, and we can actually understand at a formal level what's going on in terms of dominance of these feedbacks. So I've shown it here. If we have a sort of feedbacks illustrating here, it's infection spread, which is maybe infections, but it may be word of mouth, or it may be in-product innovation ideas or what have you. We can map out the actual dynamics of the situation coming out of a simulation model in a rigorous way and talk about which loop is dominant at which time. Okay. In other words, all these loops are operating at the same time. They're always there, having some effect, but some of them matter more for certain periods than others. Why? Because, here early on, there's very few infected people early on, lots of susceptibles. So the number of susceptibles actually decreases very quickly and the number of infectives rises quickly. Later, there's almost no susceptibles, so there's almost no one getting, or there's very, very few, and each infective is spreading it to very few additional people around because there's so few susceptibles around. And so there's very few susceptibles to get infected. So this part of the loop where we have infectives, and that leads to more contacts between susceptible infections and new infections, that's a weak loop there. It's a weak loop because this link is quite weak, okay? And there's actually tools out there, and if anyone's interested, maybe even for a project or something, and you have a mathematical bent, you could look at some of these tools. There's tools out here to take a model, to run it, and analyze which loop is dominant at which time. So which parts of the system are really driving the behaviors at this time. During this phase, it's this component. This other phase, it's this other component. And when you undertake an intervention, maybe you got to watch this area first, and then that area, more carefully control that. We'll put your resource to controlling this area or that one. So here we get shifting dominance among these loops. This is a known phenomenon, and it's mathematically rigorous to analyze it. And people have done a very good job sort of studying this phenomenon and building tools that will support that sort of analysis. Does that help? Yeah. But these loops are all operating. I mean, they're still having some effect. It's just one matters more than the other. Great question. Okay. Who would like to put a little diagram up on the board? Who would like to put it? Who wouldn't like to put a diagram up on the board?
I only have one diagram that's like a single loop.
Good. You want to put it up? Anyone else? Would you like to put your diagram up? Yeah. Okay. Okay. Do you have one loop?
No.
Okay. Okay. A couple loops.
Yeah.
Okay. You want to put it up? Yeah. This sounds great. Oh wow! Look at that. Oh man, this is beautiful. Wow.
Is there a wire? Storage.
Yeah. No, this is wonderful.
Life is.
Okay. Do you want to put it up there? I wish I could sort of show this, just like, but I don't have that capability. Maybe one of you young folks. There's a thing called Instagram. Maybe you can send it to everyone. Maybe I don't know. You don't know everyone's email. Maybe you do. Maybe you know my mother's email. I don't know. So if you want to send it to people, sure.
I can just take a photo of it, email it to you, and then put it on the board.
You can just put it on
Yeah,
the
sure.
board.
Why don't you go ahead?
I have it in my computer.
Oh, okay. Yeah, sure. All you young people have such good ideas. So yeah, if you want to send it to me in a way that even I can understand, that would be great. You want to send it as an image maybe, or send it as a model? I could open it. The problem with model is that it'll think it's a virus. It has certain types of things in it, and it will block it. So you'd have to zip it up if it's an MDL file. But yeah, Instagram it.
Yeah. You could just connect the video project to your computer.
Sure, that's an even better idea. Do you want to connect the? Are you okay with that? Connecting this to your computer. The only thing we'd lose is the ability to kind of record, like what's going on the screen. But that's okay.
Yeah.
All you have.
Yeah, you can just use your browser to
Okay.
open Instagram.
Okay. Okay. I'm not going to have to sign up for Facebook, am I? Okay. 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 So I'm glad to hear there's no.
Or you just like Instagram.
Okay. Instagram.com. This isn't going to make me young or something, is it? Sorry. A slash. I need a slash. Okay. Okay. Yeah. BAHA
REH.
REH 60.
Right.
Okay. Okay. Great. And the on top.
Yeah, the first one.
Oh, this one. Okay. Yeah. Oh. Wow, you young people are so clever. Okay, so how do if I don't want to follow you, and I certainly don't want to do that. So, so what do I do?
Yeah, right. Click on the page and the photo and
Okay,
save as.
save as. Oh, okay, okay.
Oh, it is the.
Oh, it's an HTML. Okay.
Just cross it. Just close it. The cross.
This thing. Okay, but will it close everything?
No, it won't.
Oh. Oh. Okay. Well.
Could you make an email it?
I'm sorry. Probably if I were young, it would work. Or maybe if I had Facebook, it would work. Yeah, no, that gives us a start. So the basic deal, we could start discussing this. So there's a thing called reservoir storage, and reservoir storage is quite towards the center of this. It affects water allocation to urban industry. There's a positive loop there and a negative loop because if you have more water allocated, so the more reservoir storage, the more you can allocate water to industry and urban areas. But the more of that you allocate, the less water there is in the reservoir. Now you have some things governing reservoir storage above here, like, okay, now this is interesting. Reservoir storage, the more reservoir storage you have, the more reservoir area. Okay, I'm thinking about what that means here. Does that mean the reservoir surface area, like the surface area
Yeah.
of the water is larger?
Yeah.
Okay.
And actually, the relationship is the relation between two. Actually, it's I
Yeah.
can show on the.
Okay. Okay. So there's some relationship, like you as the it's not a linear relationship. Yeah. 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 Yeah.
Surface area is this.
Yes.
But like the increase surface area is this, and so
Yeah.
the area increases.
Yeah. Yeah. Okay. Okay. That's by area though. You mean like in units? It would be sort of square meters, for example.
Yeah.
Okay. And the reservoir, what are you calling storage here? The volume of the reservoir?
Yeah, but
The volume of water.
yeah.
Okay. And then there's, as there's more surface area, that affects the volume of the evaporation, right? Because if it's super deep and only a little bit of surface area, you're not going to have as much evaporation, okay? And then you're going to have precipitation. So by height here, you mean sort of volume or level? Level?
No. Hey, because in my major, only precipitation actually measure in meter and
Oh.
details of the precipitation measures. So yeah.
Okay. Okay. So this would be sort of the amount of rainfall as measured. When you say height, it's like we got 3 millimeters of
Yeah.
rain in the past day, and this is volume taking into account the area of the reservoir. So there's a certain amount that falls within the reservoir. Now, I would think that there's some things also associated with reservoir catchment area, because there's kind of, you may have some rain falling on the reservoir surface itself, but then there's going to be some that maybe falls off here and then rolls down into that, or there's going to be a grassy area here, a woods here, I don't know.
Yeah, maybe.
It'll flow down. It just will percolate down with slower
Yeah.
speed or something. So there may be maybe some issue of catchment, which is kind of latent here, which isn't really broken out now with precipitation heights affects that, but percolation sometimes takes longer. Because like this reservoir water that falls directly on the reservoir, that's immediate increase in the volume, but it's this other one might have some delay. Now, one thing I'm not so okay, so reservoir storage. So there's storage and then there's storage capacity, but here we're dealing with sort of occupied storage, like that. And I'm saying some of these things because these might relate to some clarifications that could be put in occasionally too. But okay, so we have this water allocation, and then we have water allocation to agriculture, so that's good. And then when we have allocation to industry, that improves sort of the welfare of people, which leads to immigration rates, which increase the population size probably, because population. I mean, population. The term can mean many things, and informally we might think of population as population size, but it's a little bit ambiguous, and so putting population size makes it crisper. And then we have urban and industry demand. Water demand.
Yeah.
Okay. Right. So the more population, the more water demand, and therefore the more they're going to push for allocation of resources. Now, I would argue that one of these links, well, some of these links are quicker than others, and certainly, birth and immigration, these will occur. This is based on probably a perception, the welfare thing, in the sense that people say, oh wow, the quality of life there is really good, beautiful gardens, there's plenty of water for cattle or whatever. It's easy to grow crops in that area because there's irrigation, and therefore it attracts people. But there's probably a slower thing here, slower process there. But this is a reinforcing loop here. Why is it reinforcing? It's reinforcing because it's pushing for more allocation, and therefore you can get this sort of more and more population coming in, and this resource gets, of course, drawn down because of this loop. But here it can kind of take off, but it's a pretty slow time constant. So it may be growing exponentially, but it's at it with a slower sort of, that alpha is smaller. So it's growing, but going up over the multi-decade time frame, maybe, something like that. So here we have this water allocation to agriculture, and more it's to agriculture, the more production you have, and then you have demand. But demand comes not only from production, but it comes from the population itself. Now, the production, this is water demand. This is demand not for the agricultural goods per se, but for the water associated with it. So the more you have in production, the more irrigation is needed, etc. Right? Yeah. And hence the higher agricultural demand. And then you have some sort of max crop level requirement. That may be true. We have crop acreage. There is a question. Okay, crop acreage here is kind of shown as exogenous. You represent it. What does exogenous mean? What is exogenous? Yeah, it's an input, or it's some fixed assumption about it. Making some fixed assumption, it's not calculated by. Here, crop acreage is a little bit exogenous. You might actually say that that would be something which would be stimulated by, for example, productivity. If it's highly productive, if agriculture is very productive, people can make more money off of it. They'll want to turn some extra land into agricultural land. They'll want to plant fields where fields previously weren't, because they know that they can make a good living, with that. And so maybe the crop acreage in the broader time frame that you've got here it may be that within that same time frame, you'd want to think of crop acreage as being part of this loop as well. And remember people as part of the system, because when people see the opportunity to make a good living, to turn a profit, or to be able to sustain their families with some things, they might not only do things like immigrate, etc. They might also try to put land into production. And so we've got some elements there. Another issue is that if water is very plentiful, the type of crops that are planted might not be water conserving crops. So you consider Russia and the Aral Sea. A lot of what's happened there is that they planted highly water intensive crops like cotton in the Amudarya basin, and that soaked up a lot of water. That wouldn't be the crops you plant in that area if you didn't have a lot of water, and that led to this sort of thing dominating and eventually sucking all the water out of the rivers in a way that dried the Aral Sea up. I mean, it's a real tragedy in many ways, because the Aral Sea, there's ships abandoned on it. Maybe you can have pictures on Instagram. But there's ships abandoned around the Aral Sea. You could see where they once was a big port, and it's now just desert. And so that led to sort of planting of crops where the max crop requirement was bigger than it could be. And there's maybe I'll just comment here because I know some people will have to go. One thing to bear in mind here is that this component, so I really like this. I think this is very, very nice. I'm putting out some extra comments here, but one thing to bear in mind is that when reservoir storage and sort of available water is low, particularly when water per person is low, maybe it's some function of this, availability of water per person, then or some mismatch of demand here and supply here. There's other things that happen besides just lowering the allocation. That may be going on. But ladies and gentlemen, what sort of processes operate when things get scarce? That besides just saying, well, you get less water, there's something that operates, and it taps human creativity. Sorry? Yeah, so there's attempts to conserve water. There's attempts to, and this is where, again, the crop acreage comes in, or the type of crop. How water hungry are the crops? So you could say like water intensity of crops or something like that. That will be decreased, and also people will try to save water in terms of the ways water is provided to urban areas. So it may be that you have less leaky water tanks, or the piping is improved so there's less wastage on the way to the city or within the city. It may be that you use low flush toilets or low water use shower heads. It may be that you try to conserve water by reusing water. So you have runoff from the roof, which is used for the gardens instead of water you get from the city. So there's an issue of conservation, and what I'm thinking is that right now you do have these allocations, but it seems to me that a key component you might want to think in here, and I'd want to think about how to unpack this a little bit, is there's an issue of kind of scarcity of water, or perceived scarcity of water, and it's really perceived that will lead to that the perceived version of that will lead to this investment in conservation. So having something about like perceived availability of water as a function of population, the bigger the population, the lower the perceived availability, and the bigger reservoir storage, the higher the perceived availability, and you could have that. And if we turn this into a quantifiable model, quantified model, then we might have one divided by the other. But here we just have the negative and positive, negative for the denominator, positive for the numerator, for the polarities. associated with it. And that might lead to conservation. It might also lower the availability of crops. And similarly, when there's lots of water available, lower population, lots of storage, then you get you can get this investment in more water-intensive crops, because really that's a lot of what happens. So the eucalypti in Southern California are another example. So that's good. You look at, one thing to look at here. I really like this. So are there human elements that are additionally off here? Well, okay. One thing which happens here is there's fights between these people, these allocations. And this is actually a tricky thing. This is something I encounter a lot of years in this class. So sometimes you have a situation where, okay, so here you have water agriculture allocation, ag, and water to urban and industry. And right now it kind of shows them both as balancing loops. I would argue that in some cases, and maybe it's the case here, you have almost a zero-sum game in the sense that there's, let's put it this way, if allocation is going to go on of a certain amount to anything, it's going to have to be subdivided between the two. And so it's like one gets more, one gets less. Now maybe that's not the case here. Maybe there's always the question, well, we can leave some in storage, and so it's not quite zero-sum at all. But there may be some tension between these, and sometimes there's politics that results. In Southern California, it's huge. This is a major, major issue over decades of sort of who gets the water. Farmers, cities, you have LA, you have San Francisco, and other cities in the Bay Area, San Jose, etc. wanting water. A lot of the cities in Southern California, Orange County, San Diego, etc., they want the water. And then you have farmers on the Delta, San Francisco Bay Delta, needing water for their crops. And there's just huge acrimony and sort of fighting between them that ended up shaping things. And so one of the reasons that's important is for tensions within. If that were something you're interested in, there may be some tensions associated with sort of how much goes each way. So there's hey Alex, if you're around, I'll come find you. I won't be too much longer with the class.
Okay, I'll be in the lounge for half an hour.
That sounds great. Thanks. So one thing to realize, and this is something that comes up in a lot of models, is where you have a situation, if there's a zero sum, it's like I either, during my time, I divide my activities between relaxing, working, and shopping or something like that. If those are the three things, or if it's do I put my time into working and relaxing, then you may want to have may want to have variables where you don't just say A increases this or it increases I want to capture the fact that, right, okay, so this is the thing. Imagine if I divide my time into two things, working and relaxing, okay? My weight, okay? This is the deal. Okay. This is a really common misunderstanding, so I'm glad your models helped sort of highlight some of this. So if I increase the amount of time that I am relaxing, all the things being equal, will I be spending more time working or less? Right. Okay, less. And if I increase the amount of time working, am I going to spend more time relaxing or less? Less. Okay, so this is saying this is a positive feedback. Is that the case? No. So this is kind of a fictitious feedback. This actually isn't causal per se, it's definitional in a way. It's just like, it's where...
You said like the other thing that had trust.
Yeah.
Another thing that said mistrust.
Right. You could, and so mistrust and trust, and you say there's a negative there's a positive feedback here because you have two negatives here. That's fictitious. It's just a result of your definitions of these things that more of one yields less of the other. And causal loop diagrams are really designed to impact causal situations where they're designed to depict the situation where you're changing this will lead to some causal change in the other thing. Using it to depict this sort of definitional thing is just not sort of a proper use of a causal loop like this. So this really isn't a real positive feedback loop. So what would I do with situations with this? Well, I don't have a really great way of dealing with it, but one thing I might do is just have a variable, time for, might have something like, total time, and then I'll have a fraction of time for relaxation, and if that will impact fraction of time for work, something like that, sorry. That will sort of lower this, but I don't have a sort of feedback there, and then maybe there's some other things that affect this. So instead of trying to capture a sort of bidirectional feedback, I just have to recognize they're not in this kind of causal loop sort of situation. This is confusing. I've yet to see anyone who's fully resolved how best to represent this, but if there's a factor which can be taken as impacting one of these and just the other in a derivative way, and in other words, a resulting way through this, that may be the least bad way to do it. Or you have something like fraction of time for relaxation, and then you have total time for relaxation, and that's impacted the total time, total waking time, and the total time for relaxation, and then the total time for work, and this as a positive, this as a negative here, and this also depends on total time, sort of total waking time, something like that. Waking time. Okay, so here we have sort of some fraction. You just pick one of them, and that leads to a sort of total time for one, total time for the other. And you don't try to represent there being sort of arrows between these, because those are not causal arrows. Those are almost definitional, and you don't want to represent those. A little bit confusing. Does that make sense to people though? So the point is, these loops have to do with sort of not just definitions of how we happen to define something, that more of this means less of that, but actually some sort of causal pathway, some mechanism in the world that's typically represented. And you can kind of fool yourself if you just represent things that definitionally related to each other and try to capture their definitions through these things. There's no mechanism that per se reflects this. It's just how you define what sort of define one versus the other. Okay, so that's something that's a bit confusing. Anyone else want to? I asked you to go through a little exercise. Anyone else want to air issues that came up in that exercise? Because these things are not super easy. These causal loops diagrams are just not easy to kind of put together. They require you to stretch yourself some, be imaginative, etc. I'll open it up a little bit again, beginning with next class on Thursday, as to whether there's any more questions. Because I welcome if people want to come up and show me a diagram and I can comment on particular issues. I'd be happy to do so. I would actually say this diagram, just to give people some sense of apples and apples. This diagram is quite good. This diagram is quite very solid and advanced. So Good job. It's a good job. But some of the comments I give could be refined. I'll think a little bit more about them. But I like how you've broken out these loops into multiple features, not just had one variable for the rest of the loop, you know, and how you have multiple loops related to this. You'd want to think about if any of these other factors are endogenous, but I think that's quite good. This inflow might be endogenous if there's really high demand, maybe more efforts taken to improve inflow. And there might be this issue of catchments, which relate to this sort of availability of water. You might have a variability here, availability of water from precipitation. It's affected by this, but it's also affected by catchment area, because that catchment, and ladies and gentlemen, this is one thing I want to emphasize, by showing a variable here, you have a chance to think about what explicitly affects that. And a catchment area may be one of those things, in addition to conservation, that if you've got a real imbalance between the supply of water and demand for water, it may be the catchment areas or another thing you try to increase, but that's in tension with maybe agricultural demand because they want to turn it into fields. And so that's a tension you need to kind of work out. When I did work consulting in a country for their national government on water-related issues, one of the big tensions there is they wanted to have catchment areas for the water infrastructure that would provide water for the critical metropolitan area, but the developers wanted to build apartment buildings on that. And they argued, well, you know, the government argued, well, it helps the quality of life to have this be a kind of area people can undergo recreation in and so on. And so actually it helps the developers if this area stays as catchment area. But there was this tension between these different groups. So if that's part of the equation, as it often is, you might want to think about catchment area explicit rather than merely implicit. Because here it's kind of implicit here over what area you capture. Okay? Great diagram. Excellent start. Excellent. Okay? Okay. Any further questions or comments? Okay. I'm going to be, we've got to start thinking about projects. And I think next time I'll give a little bit of a spiel on some project ideas and suggestions. And if you have ideas for projects that you're really interested in, or maybe interested in, send them to me, okay? And I'll, if you'd like me to feature them in my description, I could. Or if you just want to say, I want to work on them with so-and-so, maybe even by yourself, just let me know, okay? Sorry?
Is it easier?
I encourage people to work in groups because I think that enlivens the situation. And it might also lead to complementary skill sets, where some people bring knowledge that's good in coding, knowledge of Java. Other people bring knowledge of some domain. I will require actually, if you have a project that you have at least some stakeholder who would like to use this after the class, okay? I'm gonna ask you to aspire. If you want to argue about why you should have a project that doesn't have that, that's fine. That stakeholder could be yourself. If you say, I want to do something for my class to be the basis for my thesis, or be for my advisor, or be for whatever, that's okay. But another thing is, I have lots of projects where we have people here on campus, people in South America, people elsewhere in Canada, people in the States, who want to use the results of these projects. They're really interested in having a project built like this, including that, and they're willing to spend time with you to help you guide the project and that sort of stuff. Really exciting. I'm asking you to have somebody who has some stake in it beyond the class length. Okay? Okay, so think about that. Okay. Yes, Kurt.
Did you open up the forum on the website?
Thank you, Kurt. I failed neglectful of my duty in this regard. I will do that right away, even as we sit here, because now I have office hours.
Great.
Okay? Very good.
It's in the middle website so that we can ask questions about that.
Great, yeah, I'm gonna set up a forum for discussion, courtesy of Kurt's suggestion.
Is this possible for you to send us the file as well as
The slides?
yeah, the slides?
Sure.
with the-
Sure. I just need pokes, so I need someone to remind me. So if I don't do it, please, I'll go try to post every one, okay? But what I think you're asking is to do it before class.
Yeah, exactly.
Okay, I will do my best to do that. And I would suggest if we're here before class and you don't see it yet, you could ask me and I could probably just go do it then. Okay? Good. Good. Sure. Thank you, everyone. I will, for video for next time, I'm going to ask you to watch a video on system dynamics, okay? And it's going to provide more of an introduction to system dynamics, so we could discuss that next time. So this will be stocks and flows specifically, okay? And we're going to link that in to causal loop diagrams, but we're going to be next time seeing how it can be used to do runnable models. Models can be simulated over time. You can see the behavior. I will also provide, if I can, a pointer to some group model building. So if anyone's interested in system dynamics being used with community groups to kind of, at a group basis, build up models to help understand how they understand a situation and so on, there's some videos I might be able to provide for that. I'll see if I could provide a link for anyone who's interested, okay? Very good. Thank you.